On 28, solve by the method of your choice. So your choice could be graphing. I'm going to put graphing with a question mark. If I have a choice, I'm not going to do graphing. I'm going to write, not me. You might want to do graphing, but I'm not. I could do the addition method. That's not bad. Here I could multiply the second equation by 2, and that would take care of the problem. I could do the substitution method. That wouldn't be bad either. I could take the second equation and solve it for y and substitute it into the first one. I'm going to do the addition method. Now my first thought was substitution, but I like the question that was raised a few minutes ago, and I'm going to take that approach with, I don't have to multiply both equations all the time. Here's my first equation. Here's my second equation. And as I look at these two, I'm going to take the second equation and multiply it by 2. Oh, not yet. I got to distribute it first. And then the first equation is just going to stay exactly what it was. So when I distribute that 2, I'll end up with, now I'm going to recopy the first equation first. 7x minus 2y equals 16. The second equation, I get 10x plus 2y equals 52. Then I can add them together. The two y's cancel. 7x plus 10y is 17x. And 16 plus 52, I'm going to use my calculator for that because I'm feeling kind of lazy. Right there. 68. 17x equals 68. That's 17 times x. The opposite of times is division. So we divide both sides by 17. And then x is 68 divided by 17 is 4. I need to find y. I will plug that number in for x. I'm going to go with the second equation because as I look at the two equations, I got that minus 2y, and maybe if I don't have to deal with a negative number, might be a little easier. Those are just questions you can kind of process in your head. I'm going with 5x plus y equals 26. So 5 times 4 plus y is 26. 5 times 4 is 20. 20 plus y equals 26. Let's do minus 20 from both sides, and I get y equals 6. So my answer, solving by the method of my choice, was 4, 6. That's an ordered pair. Would I have gotten the same answer if I'd have used substitution? Yes. I've had students who that were surprised about that. Years ago, it was, I worked a problem one way and then I worked it another way, and the students raised their hand and they said, oh, you mean if I work that with substitution, I'll get the same answer? And yes, you will get the same answer. Because it's the same problem. It's the same, it should have the same answer.